Title of the first section is Graph and Ellipse. First equation, inside parentheses, x minus 3 squared divided by 16 plus inside parentheses y plus 2 squared divided by 9 equals 1. This is in standard form for an ellipse, where you have x and y on the same side, both squared, each one divided by a number, and it has to be equal to 1. To find the center of the ellipse, the x value again, we'll take the opposite of that number, which would be 3, and the y value would be negative 2. Instead of a radius, we'll have a major and minor axis. The major will be the bigger number underneath the fraction, which would be 16. But just like the radius from the circle, we'll take the square root, which would be 4. After the 4, since the 16's underneath the x on the fraction, we'll put an x, so this will be 4 units in the x direction. For the minor axis, we'll take the smaller number underneath the fraction, which would be 9. And again, taking the square root would be 3. And since the 9 is underneath the y, we'll put a y next to it, so this will be 3 units in the y direction. And last part for the foci. The equation is a squared minus b squared equals c squared, where a squared and b squared are the two numbers underneath the fraction. So 16 minus 9 would be 7. That's equal to b squared though, so the foci distance would be the square root of that, or square root of 7. To graph from here, we can draw the xy axis. The center again would be at 3, negative 2. The major axis is 4 units in the x direction. So in the x direction, which would be left and right, we'll go 4 units each way. So 4 units to the right and 4 units to the left. For the minor axis, which would be shorter, in the y direction will only be 3 units. So we'll go 3 units up and 3 units down. So it's almost like a circle, except you have 2 different directions. We have 4 going left and right, and 3 going up and down. If we connect these, that will get us the ellipse shape, which is a oval shape. And the last part, we want the foci distance. The foci will be 2 points inside the ellipse. From the center, it goes in the major axis direction. So we'll go in the x direction, and it'll go square root of 7, which is a little bit less than 3. So we'll have 2 points inside the ellipse for the 2 foci points. Second question and last question for the section is y squared over 10 plus x squared over 5 equals 1. Again, this is in standard form for an ellipse. If we have x and y squared, both in fraction form, and it's equal to 1. First part for an ellipse, we'll find the center. The x value again would come from the x. If there's no number next to it, the center would be 0. And the same thing for y. There's no number next to it, so the center would be 0, 0. The major axis, again, is the bigger number underneath the fraction, which would be 10. The major axis would be the square root of 10, which would be just over 3. And again, this comes from the fraction with the y, so this time the major axis will be in the y direction. The minor axis is the smaller number, which would be 5. And again, underneath the x, so this will go in the x direction, and we always take the square root to find the minor and major axis. Last part for the foci. We'll subtract again a squared and b squared, the two numbers underneath the fractions, which would be 5. And to solve for b again, we'll take the square root. So the foci distance would be the square root of 5, which would be just over 2. To graph this, we can draw the xy axis. The center is 0, 0 in the middle. The major axis in the y direction, which will go vertically, up and down. Square root of 10 is just over 3. So we'll go just past 3 up, and just past -3 down. Square root of 5 is just over 2. So we'll go a little over 2 to the right, and a little over 2 to the left. And again, you can connect them to make the oval shape. I'd say oval because the distances are different in the x and y direction. The foci again always goes in the major axis direction. So in the y direction, the two foci would be square root of 5, or about 2 spots up, and just over 2 spots down. And that would be the graph for the ellipse. Title of the last section is Graph a Hyperbola. First equation is x squared over 81 minus y squared over 49 equals 1. Again, this is in standard form for a hyperbola. If you have x squared and y squared on the same side, both a fraction, and instead of a plus sign, you have a minus sign, and it's always equal to 1. First step, we want to find the center. The center, again, would be the opposite numbers next to x and y. Neither have numbers, so the center would be 0, 0. For a, it'll be the number underneath the x, which is 81. Taking the square root of 81, that would be 9, and that would be 9 in the x direction. Same thing for the number underneath y. We'll take the square root, which would be 7, and we'll put 7 units in the y direction. From here we can graph. The center would be in the middle. 9 units in the x direction from the center. We'll go 9 units to the left and also 9 units to the right. Also for the y value, we'll go 7 units. That'll be 7 units up and 7 units down. Instead of connecting these to make a circle or oval shape, we'll connect these to make a box. will basically go straight off to the left, then straight down through each point, and then straight to the right, and straight up, and connect it to make a box. So it goes through each of the 4 points that we drew. To make the diagonals, we'll go from one corner of the box to the other, and we'll go through the center, and we'll pass through the corners of the box and extend it out a little bit so we have the diagonals outside the box. And we'll do that in each direction. From here, we can draw the hyperbola, which is basically two parabolas. The parabolas either open on the x-axis, which would be horizontally, or they open vertically on the y-axis. To determine which one, look back at the original equation. We have x squared minus y squared. Whichever variable goes first, that's the direction it would go. So the x-axis would have the two parabolas, and they go parallel to all the dashed lines. They'll connect to the point that we had at the end of the box, and continue to go parallel next to the other dashed lines. And this will be one parabola shape on the left side, then we'll have another one on the right side. And again, it connects to the point on the right, goes parallel and gets close to, but does not cross the dashed lines, which are like asymptotes. And you have the two parabola shapes, which together are the hyperbolas. The last part's the foci distance. For the foci distance, we'll have 2 points inside each of these parabolas. To find the distance, we'll add the two numbers we had before, a squared plus b squared. So 81 plus 49, that would be 130. Taking the square root of that would be just over 11. So if we go back to our center was 9 spots out. If we go 2 more spots and a little bit past, that's where the first foci would be. And the same thing on the right side. And that would finish the graph for the hyperbola. Second graph and last equation for the section is y minus 2 squared divided by 4 minus x plus 1 squared divided by 9 equals 1. And again, this is in standard form. We have x and y squared on the same side, both in fraction form, with a minus sign between them, and it's equal to 1. To find the center, again, the opposite of the x value would be negative 1, and the opposite of the y value would be positive 2. For the two numbers, it doesn't matter which order you do them in. You can do the first number, which would be 4. Always take the square root, which would be 2. And again, this is underneath the y fraction, so this would be 2 units in the y direction. The second number, 9, the square root would be 3. This is on the x fraction, so that's 3 units in the x direction. If you want to do the foci before your graph, 4 plus 9 would be 13. And the square root of 13 would be a little over 3 and less than 4. And again, those will go inside the parabola shapes after we graph. To graph the hyperbola, we can draw the xy axis. The center again is negative 1, positive 2. We're going to go 2 units in the y direction, so that would be 2 units up and 2 units down. We'll go 3 units in the x direction from the center, so 3 units to the right and 3 units to the left. Again, for a hyperbola, instead of connecting the points to make a circular shape, we will connect them to make a dashed box, which will go straight through all 4 points to make a box that we can draw the diagonals through and then draw the hyperbola. After you draw the box, we'll draw the diagonals that go through the corners and through the center and extend out past the box on both sides. To draw the parabola from here, or hyperbola from here, we can decide which direction it goes. Looking at the fraction, or the original equation, we have y minus x, so the hyperbola will go in the y direction, which means the hyperbolas will open up and down vertically. And again, you connect it to the point on the box. It doesn't go inside the box, it doesn't cross the dashed lines, but it'll continue on as a parabola shape. Same thing on the bottom, it'll connect to that point on the box and go parallel and right next to all the dashed lines. For the foci, square root of 13, it's a little bit more than 3. In the y direction, we went 2 spots up, so the foci would be just above 3 spots in each direction. And that would be the graph for the hyperbola.